it's not. This is kind of this different dimension. On horizontal axis, it's a measure of how fast it rotates. So this wide echo, it just means that the primary is rotating really fast, so period less than 4 hours. And the little in the back, the narrow echo, just means that this asteroid is rotating really slowly, probably periods of less than 1 day, but many, many hours.
Well, you sent us a video earlier today to give us an example. You think that there are great similarities between QE2 and another asteroid that you have, and we can roll that too.
Yes, well, so far we know that about 16% of asteroids in the near-Earth population that have diameters greater than 200 meters, we know they're binaries. And this is one well-studied binary. This is based on a reconstruction of radar data. And when you reconstruct what radar data really means, you end up with this three-dimensional shape model. And this is asteroid 1999 KW4. And it's one of the best studies binaries. You see its primary rotating really rapidly, and then you see the satellite that is in the orbit around its primary. The reason why the binary asteroids are so important is because we can estimate the mass of the asteroids. And if you know the size, then you can estimate the density, and you can estimate the internal structure. And from here, you can infer things about the collisional history of the asteroid, and in general about the processes that shaped the terrestrial planets and the main belt asteroids.
So you're able to get more information. This is information that could be used for missions. I understand that we used radar information to help us with missions like the Hartley 2 mission, in fact.
Yes, that is correct. We frequently, on several occasions, we radar provided a really key kind of data that helped make the mission kind of, they optimized their navigation sequence, and they just planned it's possible to plan a much safer, more efficient mission if you know how the object looks like prior of getting there.
And people are always concerned about the orbit of these asteroids, that they could be on a collision course with the Earth. And there are times where we think, oh, it looks like it, but then as we get more and more information, like the information we're getting today, we can refine those orbits, and we will be able to refine it again after this observation, correct?
Yeah, that is correct. So one of the really kind of powers of radar is that it can locate where the asteroid is very precisely. It provides this very tight point in its orbit and refines it, and based on that you can kind of extend the orbit of that object centuries in advance, and you can know exactly, you can better assess the risk of potentially the asteroid hitting the Earth.
Well, before you go away, Marina, we have a couple of questions from the social media audience. These are questions that were posted on our Twitter page for Asteroid Watch, and here's one that's for you. What is the frequency of the radar that you use, and how big is your transceiver, and where is it located?
Okay, so we are working with two radars. They're only currently, we are working with a radar at Arecibo. We are working radar at Goldstone. So Goldstone, this is a 70-meter antenna. It's transmitting at 8560 megahertz. We have 500 kilowatts of power. And then at Arecibo, we have 300-meter diameter dish. And that one is 1 megawatt power transmitter, and it's transmitting in 2380 megahertz. Arecibo is about 20 times more sensitive than Goldstone, but Goldstone can cover much more of the sky because we have fully steerable antenna. So in effect, these two systems are really complementary.
All right, here's another question from Asteroid Watch. Is the radar a ground-based or space radar to track celestial objects?
Well, space radars are used constantly in the missions, but kind of just to get the science data. But it's really not necessary to have a kind of space radar. We already are doing quite a bit of work with these two radars that we have on Earth.
All right. So those are two questions from Asteroid Watch. And if you also have questions yourself that you would want to send them in to us, go ahead to our Twitter page at Asteroid Watch, twitter.com/. Asteroid Watch. Thanks, Marina. We look forward to seeing more results on this data. 1998 QE2 should be a great radar target from today all the way through June 9th. Thanks, Marina.
Thank you very much.
And as we mentioned, seeing 1998 QE2 can be a challenge. It is small, it is faint, and it moves slowly. You won't be able to see the asteroid with the naked eye or even binoculars because it's 15 times as far away as the moon. But if you have the right telescope and know where to look, backyard astronomers will be able to see it, and that's why we pulled in Steve Whistler. Steve is a JPL system engineer that's worked on missions like Deep Impact and Epoxy, and he's also a trained astronomer who works with the amateur community. Now, Steve, you spotted QE2 yourself yesterday on your own telescope.
That's right. I set it up last night, and fortunately I had clear weather, and I got about 40 minutes worth of imaging out of it. And yeah, so it's definitely possible to see with a small amateur telescope, even from a near JPL here where there's a lot of light pollution.
We have the picture that you sent us. We could put it up.
The small little smudge there is the asteroid. There's a reference star that I put in there, but it was fairly easy to set up and see. You need to know where to look, and the best way to find out is to download the coordinates from JPL's Horizon website. I entered them into my computer and told the telescope to point there.
So let's back up a little bit. So how bright was it?
It's 11th magnitude, so it's about 100 times fainter than can be seen with the naked eye. This is why you wouldn't be able to see it in binoculars either. And again, it moves so slowly, it would be very hard to see visually just looking through the telescope. The image there was 30 seconds, and so there was just a very faint smudge in 30 seconds. So photographically, it's much more interesting.
Well, folks will want to ask, what size telescope did you use?
I used a 10-inch telescope.
And we have pictures of ones here, too, as well, that we can cut to. How large is this one?
That looks to be on the order of 12 inches, 12 to 14 inches. That is not a computer-controlled telescope, and would be relatively hard to find it in that.
In this case, this one would be tough.
Yes. Yeah.
Because
you really need a good star chart to understand what the background star field is going to look like, and understand where the asteroid will be relative to those stars. And then it's not too hard to do.
So to help folks along, we could provide them a little bit of a star chart. We created one for them. We can take a look, and you can help them with this.
Sure. Now this will show the path of the asteroid through the night sky. It's got a southern declination, so it is visible from Los Angeles. Tomorrow night it'll get as high as 37 degrees above the horizon. The further south you go, the better. Further north, it's going to be a little bit worse. You would need a detailed star chart with the surrounding stars that you would be able to see from your telescope in order to really pick it out and understand where it is relative to the stars. Because it is going to look like a star. Even in the Hubble Space Telescope, it would look like a star.
How many days would we have this viewing opportunity?
That I am not sure of. Certainly a few more days it would be visible.
So definitely look for it in the southern skies.
Right. But again, if you go to Horizon's website, or there's a number of other websites where you can download information that will tell you its position and magnitude for every day.
So a lot of people aren't aware of this, that there are telescopes that you can just take this orbital information, download it into your telescope and computer, and it looks for it for you.
That's right.
So where would you get information like that?
There's a number of sites that have the orbital elements. Again, JPL's Horizon website is what I used. And
there we have it on the screen for you. It's ssd.jpl.nasa.gov/horizons.cgi. And the target body that they type in is this number?
That is the JPL ID for the target.
And that number is 285263.
That's correct.
So folks who probably are going to be pretty sophisticated, have sophisticated computers and telescopes, will be able to get
Most
this.
amateur telescopes sold today have computer control of some sort.
All right, but if you have one that you would have to focus yourself, it's going to be a little tough.
Yes.
Okay. So we have a couple of social media questions for you, Steve. The first one is, am I going to be able to see it in South Florida?
Oh, yes, definitely.
Actually, probably better than
than here. Assuming it's not cloudy. Yeah.
All right. So so pretty much all over the United States we should be able to see it.
Yeah. I really couldn't say for like San Francisco and above. Again, it's going to be really low in the horizon the further north you go. But certainly from the southern United States, it'll be easily visible.
All right. Some other questions. This would be probably more towards folks who are worried about asteroids, and
Okay.
I don't think that that would be good for you. Just rules of thumb advice for people who want to do this, especially first-timers. Should they go to, various planetariums or something like that? Would that be helpful?
It's really helpful to join an astronomy club to learn, because talking to people and seeing how they do it is one of the best ways to learn this hobby.
And websites to kind of help people
Lots of great
along?
information on the websites as well.
All right.
Yahoo groups, those sorts of things.
I should plug our own normal feature. We have a feature on our own video website here at JPL, the What's Up series.
That's correct, yeah.
Every single month, we will tell you what to look for in the night sky.
Yeah.
So that's another one to keep in mind. Well, Steve, thank you. Thanks for the tips
welcome.
and the advice. And many of you who have probably the more sophisticated telescopes will be able to see QE2. So you will be able to see 1998 QE2 in your own backyard, but some of you won't. But don't despair. We have one more way for you to track this asteroid. It's a visualization tool developed here at JPL. It is called Eyes on the Solar System. Visualization producer Doug Ellison is here in Mission Control right now to give folks tips on how to use it. Doug?
Thanks, Gay. Well, good morning, everybody. And some of you, I'm sure, have already used our tool called Eyes on the Solar System. For those of you that haven't, you need any Java-enabled web browser on a Mac or a PC, and you just need to go to this website here. It's at eyes.nasa.gov. Now, the next few minutes, I'm going to give you a brief tour of a few interesting things in Eyes on the Solar System you can look at over the next year or so, and show you how you can ride on board with 1998 QE2 as well over the next few days. Let's go and have a look at Eyes on the Solar System. As you can see right here, what we have is essentially a live view of where QE2 is right now, using the very same trajectory data that Steve was just talking about. And you can see that it's about 3.6 million miles from the Earth, and we can take a look at the asteroid. Of course, the news that QE2 has a small moon was a surprise to all of us, and so we'll be adding that in the next few weeks to give QE2 the most accurate representation we can. But let's leave this little module for now and go and look at some other things in and around our solar system that might be interesting. Things that people may not have figured out for themselves in Eyes on the Solar System before. I'm going to go and click on the Visual Controls tab in the bottom right-hand corner here, and way up at the top, under the different sections, the layers of objects we have in Eyes on the Solar System, there's a section called Small Bodies. That's where we keep things like asteroids and comets. Now I'm going to turn on the comets layer, and you can see Eyes on the Solar System gets actually quite busy. You can see our old friend Hartley 2 that we explored with the Epoxy spacecraft, Comet Elenin over here, Halley's Comet, of course. But two comets in particular are going to be very, very exciting over the next year or so. I'm going to go and look at Comet Ison. You can see its orbit here. If we start fast-forwarding through time, we're looking at May. This control down here, we can actually skip forwards. And now we're seeing Comet Ison screen towards the inner solar system. You can see right there, in October of this year, it actually gets pretty close to the planet Mars. Let's go and see just how close that is. We can double-click on an object and ride on board with it. I'm going to zoom out just a little bit so we can have a look at the coma around the comet. And I can right-click on any object in Eyes on the Solar System, measure the distance from something, click on something else, and now I've got a virtual tape measure through space that tells me how far apart these two objects are. At this point, you can see that Mars and Comet Ison in October of 2013 are about 10 million miles apart, and they get to within about 8 million miles. I'm going to back out to the whole of the solar system again with the Home button, and I'm going to keep fast-forwarding, and eventually you'll see Comet Ison get incredibly close to the Sun. It's an incredibly close flyby, something known as a sun-grazing comet. It gets so close. Now, if it survives that incredibly close approach to the Sun, it's going to be a spectacular comet for people to see from the Earth at the end of this year and the beginning of next year. Now, let's go look at a different asteroid, a different comet. What I'm going to look at now is the one discovered by the Siding Springs Observatory. It's right down here, called 2013 A1. Here it is. I'm going to go right on board the comet. And you can see right now it's way, way out below the solar system. And I'm going to actually lock the camera from the shoulder of this comet onto the planet Mars. Let's lock the camera by right-clicking the mouse and hitting lock on. And I'm going to fast forward, and you can see we're now getting through November, December, and I'm going to keep going. You can see the MAVEN spacecraft gets to Mars not long before this comet flies past. And towards the end of next year, there you saw it, very, very quick flyby. I was fast-forwarding a little bit too quick. Let's rewind time and look at that flyby in a little bit more detail.